whatever time it is for you. This is Chapter 9, Quality of Service Implementation. So this is the lab we're going to configure. So we're talking about the class map. The name is voice, and then RTP is your protocol. Here's another class map. HTTP is the name. HTTP is a protocol. And once again, ICMP is the name, ICMP protocol. Here's your policy, class voice, priority 100, and then here's your DSCP and EF. We'll talk about that in a second. And you can see the HTTP has different settings of bandwidth, a different DSCP, and same with ICMP. And then if you notice the name Mark is repeated down here on the interface. So this is very similar to our ACLs, applying them to the interface. So if you notice here, we have the Ethernet frame on the far right. And then 802.q is your VLAN.1q. And then that's on the outside. And now we're adding another class of service. And it's going to be, here's your priority field. And then your CFI and VLAN ID, it's the 802.1p. So to avoid packet loss and congestion, it's on the interface. Most TCP experiences slow down and it automatically will adjust. So drop TCP segments can reduce their window size. If you don't remember, window size is actual file size or how many packets you're sending, which means how much you can send at one time. So the file size will grow by the number of packets. And we're talking about fragile flows, so you don't want those to have drop. So to prevent drops on sensitive applications, we can increase link capacity, which would cost money. And then also we can prevent the congestion before it starts. So to guarantee bandwidth, we can increase buffer. We can account for bursts and fragile flows. And the techniques that we will use will be the weighted fair queue, the CBWFQ, and the LLQ. We'll talk about those later. And to drop lower priority packets, we use Cisco's WRED. So here's your random early detection. This is the non-Cisco, this is the industry standard, so it's non-Cisco. Here's your queue. So let's say we have 25 packets as our minimum threshold, 45 packets will be the maximum. So if we're down around 27, we can guarantee some lower packets will be dropped. If we're up around 45, then maybe some higher priority packets will be dropped. This is a little scary, but we break it down. So here's your 25%, here's your 35%. That's our safe zones, but we're still guaranteed between 25, 27, 30, we maybe have some lower priority drops. So to classify the priority, we use binary. So we're using 0, 1, 1, which is 3. That's the first packets that are dropped. 2 will be the second packets dropped. And if you are 0, 0, 1, you are the highest priority. So the tools we use will be used to analyze traffic class. The traffic class is determined with the packets are marked. We use the WRED for congestion avoidance. And then here's your class-based weighted fair queuing and your low latency queuing. These are the algorithms I use. So the first thing we're going to do is classify the packets by marking them. Then we policy and select dropping. So looks like the greenish is going to be the highest priority, orange second, green, and then yellow will be the first packets that will be dropped. Then you queue them and you see the green is going through without dropping, and then so your ingress and then your egress, similar to ACLs. So once you get in the queue, then you get the flow, and then you can see that green gets more than orange, and the queue is down and so forth. So the priority is working. And the policies I consider, if you do any server, the group policy, edit group policy, that's kind of similar. So we're going to use layer 2 and layer 3 interfaces. We're going to use also ACLs and class maps. Layers 4 through 7 can be help with congestion, but it's going to use a network-based application recognition, which we don't have. We can actually put marking on non-IP traffic. Only quality service option is available on non-IP aware switches. Layer 3 will carry the quality of service to the end. And then here's our quality of service tools and the marking classes. And then here's your width in bits. So you can see they're layer 2, they're 3 width, and then there's a 6. So within the Ethernet frame, we have a field, 2 fields, and we're going to use it for 8021P, user priority. So it's 3 bits. And if we use 3 bits, we get a total of 8, 0 through 7. And then the CFI and the VLAN ID. So here's our 8 values for the quality of service prioritization. So 000 is best effort, 01, medium, then high is 2, 3, 4. So notice as you get higher, you're getting the voice and video and voice, which we want to have at the front of the quality of service. So if you've never watched the pattern, we go zeros, we fill the ones to the right, then it goes to the next spot, then we fill backwards. Then we fill up to the left, then we go back to the right, then we got to fill these 2, and then back to the right. So within your layer 3, you're going to use type of service, and with layer IPv6, you're going to use traffic class, and it's a 8-bit field, so you'll have 0 to 255. So the type of service is 6 bits, and we're using it for what they call the differentiated services code point. And we'll see these in our config. We saw it earlier, we'll see it again in the ECN. So if you look at 6 bits in binary, it's 64. And then you have your ECN is 2 bits. So here's your best effort. Equivalent is going to be value of 0. Expedient will be a value of 3. And then your assured will be the 5th most significant bit. So the AFXY formula is the first 3 most significant bits to designate the class. So the worst queue is first to drop. So the 4th and 5th significant bits are used to designate the drop preference, and the 6th most significant bit is set to 0. So you can see that you have the AFXY formula, your drop preference, and then your DCP value. You add them all up in binary, and you add up to 28. So these are your classes, 4, 3, 2, 1. And over here is your DSCP. So it's using 3 bits. We know that a nibble is 4. So what is 3? So if we look at the value of the class of service, 0 matches up DF 0. And then 1 comes over to equal 8, because if you add the 2 zeros here, and then so on and so forth, 16. So these are the 3 most left significant bits. So what is 3 bits? These are the terms I found on the internet. So when we have traffic, we have classified, and it's marked closest to the source, and it's a trusted boundary. So layer 2, cost of service, and or layer 3, layer 3 DSCP values. So the secure endpoints at layer 3, or the secure endpoints can be marked at a layer 2 switch, and traffic can also be marked at layer 3 switches and routers. So if we look here, we can see that the phone is trusted because it's within the network. This switch is untrusted. So you can see where the trust boundary exists. So to avoid congestion, we want to monitor traffic, anticipate congestion. Our bottlenecks, our biggest problem for congestion. We're going to monitor average depth of the queue. If it's below minimum thresholds, no drops. If it's max thresholds, small percentage of packets are dropped. And then when the maximum threshold is passed, all packets are dropped. So that we never want that queue to fill up. I think that's one of our hacks we can work on. So to avoid congestion, you're going to use the WRED, Cisco Preparatory, and it helps drop tail drops and TCP-based applications. So shaping and policy. So you can see that in the diagrams here, before shaping occurs, we have peaks and valleys. So it retains excess in a queue and schedules later transmission over time, and it gives a smooth output rate. Shaping is on the outbound concept, and policy is on the inbound. So we'll have to remember that when we do the inbound outbound on our config. So if you look at shaping, then it flatlines over time because it's able to schedule those packets out of the queue. So policy is for inbound traffic. And if we are doing it with a customer, you're going to be at the CIR, the contracted customer rate information rate. And if it allows bursting, that will help also experience congestion. So it basically what the ISP gives you, that's what your contracted customer information rate is. So to the quality of service policies, so you enable queuing at the device and in the path of the source and destination. So you queue all the way from source to end. You classify and mark traffic at the source. You shape and policy traffic closest to the sources as possible. So standard ACLs close to destination, extended close to source. So that's your quality of service.